Yes, very good evening, students. This is date 5th November 2020. Homework video solutions. Homework video solutions. So that is homework video solutions. Topic chemical kinetics. Date 5/11/20. Level 1 from mains material. Okay, from mains material. Question number level 1, question number 22. The product of half-life and the square of initial concentration of the reactant is constant. Then order of the reaction is, yes, question number 22. You can see that is a mains material. Mains practice book. Page number 23. Yes, that is the product of life, half-life T off and the square of initial concentration of the reactant A is constant. Then the order of the reaction is, see, you know that T half is inversely proportional to the A by A to the power of n minus 1. Here A is called initial concentration and n is called order of the reaction. Order of the reaction. Yes, for first order, that is a T half 1 by A to the power of 0. Okay, for second order, T half 1 by A. Then for third order, T half is 1 by A square. So answer is 3. That is third order. Then 50% completion of first order reaction takes place in 60 minutes. Then the fraction that would react in 32 minutes from the beginning. Yes, they have given here, question number 23. They have given, that is T half is equal to 16 minutes. So after 32 minutes means, that is 2 half-lives. So what is the fraction that would react in 32 minutes from the beginning? That is a 3 by 4. Okay, then question number 24. Out of 300 grams, decomposes as per first order, how much nearly will remain after 18 hours? Yes. Original quantity is, what is the original quantity given? That is 300 is equal to 300 grams. Okay, 300 grams. Then T half they are given, that is equal to 3 hours. Then number of half lives, number of half lives, that is equal to 18 hours by 3 hours, that is equal to 6. Yes, after 18 hours, 18 hours, 1 by 2 to the power of 6 of the original substance is remaining. Original substance is remaining. Remaining is equal to 1 by 64 into 300, that is a 4.68 grams. Got it? Then question number 25. 75% of first order process is completed in 30 minutes. The time required for 93.75% completion of the same process in hours. They have given time in minutes here, 30 minutes. But they are asking the completion of 93.75% reaction in hours. So what is the formula? K is equal to 2.303 by T log R naught by R. So K is equal to 2.303 by 30 log 100 by 25. Sorry, yes, that is 75% is completed. So remaining 25%. K is equal to 2.303 by 30 log 4. Okay. Then K is equal to 2.303 by 30 log 4 value 0.6021. So then K value is equal to 0.046. Then if you got the K value, oi, oi, log 16 value. Yes. 16 T 93.75 LAN alla kana lago 75% is equal to 2.303 by K log R naught by R. Okay. So T 93.75% is equal to 2.303 by 0.046 log 100 by 6.25. So T 93.75% is equal to 2.303 by 0.046 log 16. So T 93.75% is equal to 2.303 by 0.046 into 1.2041. So that gives us 60 minutes. That is equal to 1 hour. Okay, that is T 93.75% in hours is equal to 1 hour. Then level 2. So page number 24. Same topic, 24. Yeah. Question number 1. For the reaction A is equal to 0, then K is equal to 3.2 into 10 power 4 per second at 300 Kelvin. The value of K at 310 Kelvin. Yes, what is the formula? You know that log K2 by K1 is equal to EA by 2.303 R T2 minus T1 by T1 T2. So if A is 0 means A is equal to 0, then K is equal to A is equal to constant. So 3.2 into 10 power 4 per second only. Then the rate constant K for the reaction is 2.3 into 10 power minus 2 per second, which equation given below describe the change of N2O5 with the time. N2O5 0 and N2O5 T corresponds to the concentration of N2O5 initially and at the time T. So which is the correct one? Very simple one. Asking very simple one, that is it is a first order reaction. Second one, that is a first order reaction ln N2O5 initial concentration by concentration of N2O5 at a given time is equal to KT. Then third question, the rate of reaction for the rate reaction for the reaction to A plus B gives rise to C is found to be rate is equal to K into A into B. The correct statement in relation to this reaction is the, yes, that is third one. The value of K is independent of the initial concentration of A and B. The value of K is initial concentration of A and B is what? Correct statement. Then fourth question, the rate law for a reaction between the substances A and B is given by rate is equal to K into A to the power of, yes, fourth one, rate is equal to K into A to the power n and B into, sorry, B to the power of m into B to the power of, and doubling the concentration of A and halving the concentration of B, the ratio of the new rate of the earlier rate of new rate to the earlier rate of the reaction will be, yes, that is R is equal to K into A to the power of n and B to the power of m. This is the equation 1. Then R1 is equal to K into doubling the concentration of A and halving the concentration of B. Then equation 2 by equation 1, that is R1 by R is equal to 2 to the power of n minus m. Then R1 is equal to 2 to the power of n minus mr. So the option fourth one is correct. Yes. Hydrogenation of vegetable ghee at 25 degrees Celsius reduces pressure of hydrogen from 2 atmosphere to 1.2 atmosphere in 15 minutes. The rate of reaction in terms of molarity per second. Yes. Fifth question, that is initial pressure of hydrogen, that is equal to 2 atm. Final pressure of hydrogen, that is equal to 1.2 atm. Delta T they have given, that is a 50 minutes. Got it? Then dP by dt by 0.8 by 50, that is equal to 0.016 atmosphere per minute. Per minute. Then you know the value, oh sorry, equation PV is equal to nRT. Then P by RT is equal to N by V, that is equal to molarity. What is molarity? That is the number of moles by volume of solution in liters. So M1 is equal to P1 by RT. So P1 is 2 by 0.082 into 298 Kelvin. So you will get 0.08 molarity. First one. Then another one, M1 is equal to P2 by RT. P2 is here 1.2 by 0.082, 1 into 298 Kelvin. Then M1 is equal to 0.05 mole. So rate is equal to minus change in molarity by dt, that is equal to 0.05 minus 0.08 by 50 into 60. So you'll get 1 into 10 power minus 5. Second option is right. Then sixth one. For a reaction 2SO2 plus O2 gives rise to 2SO3, rate of consumption of SO2 is 6.4 into 10 power minus 3 kg per second. The rate of formation of SO3. Yes. So of d SO3 by dt is equal to, they have given 6.4 into 10 power minus 3 kg per second. So that is equal to 6.4 into 10 power minus 3 by 80. Then minus half dSO2 by dt is equal to, according to the rate law expression, dt, that is equal to 6.4 into 10 power minus 3 by 80. So that gives 0.08 into 10 power minus 3, 8 into 10 power minus 3 kg per second. Okay. Then seventh one, a gaseous reaction A2 A2 gives rise to B plus of C, shows increase of pressure from 100 mm to 120 mm in 5 minutes. The rate of disappearance of A2 is, yes, what is the reaction? A2 gives rise to B plus half C. So that is 100 minus x and x plus x by 2. So 100 plus x by 2 is equal to 120. Then x is equal to 40. So the rate is equal to dx by dt, that is equal to 40 by 5. So 8 mm per minute. Got it? Then eighth question. Concentration of reactant A is changed from 0.44 mm to 0.032 mm in 25 minutes. The average rate of the reaction during this interval is average rate of reaction. What is average rate of reaction? The reaction at definite intervals of time. So rate average is equal to 0.044 minus 0.032 by 25. Okay. So that gives 0.00048. So 4.8 into 10 power minus 4 mole per liter per minute. Ninth question. For a 2a plus b plus c gives rise to products, the rate law given by rate is equal to k into a into b square, and the rate constant is 2 into 10 power minus 6 mole per second. Then rate of the reaction becomes 2 into 10 power minus 9 mole per second only when, that is in a third option, that is the concentration of A is equal to A concentration is equal to 0.1, B concentration is equal to 0.1, and the concentration of C is also 0.1 moles. Because very simple one, according to given data, C is independent. C is independent. That is option C is correct. Third option is correct. Rate expression for XA plus YB gives rise to products is rate is equal to K into A to the power of M and B to the power of N. Units of K with respect to A and B. Yes, with respect to A, unit of K is equal to per second. That means it is a first order. Then with respect to B, per mole per second. Per second, that is a second order. Concentration of A and B are increased by 4 times. Then according to units with respect to A first order and with respect to B second order, then final rate is equal to 64 times of initial rate. So fourth option is correct. So this is video solutions for that 5th November 2020 topic chemical kinetics level 1 and level 2 questions. See you students. Bye.